Hey, Math 85 students, today we're wrapping up section 5.7 on square roots. So first we should recognize what a square of a number is. The square of a number n, it's written n with the power 2, and it really just means n times itself, like with two factors. So for example, 9 is the square of 3 because 9 is equal to 3 squared, which is really 3 times 3. Right? So why is 9 called a square number? So this does come from geometry. Imagine that you have a square that's, say, 3 feet on one side and 3 feet on the other. The area of the space inside, let's see if I can break this up correctly. It's like 1 foot, 2 foot, 3 feet by 1, 2, 3 feet. There are 9 little squares inside. Each square is 1 foot by 1 foot, or this is like 1 right here. This is 1 square foot right there. So there are 9 of these square feet taking up the inside of the square. So we say the area is 9 square feet. So 9 is a square number because it can be rearranged into, if you have 9 squares, they can be arranged to form a larger square that is the same amount on each side. And you want to compare that to a number like 6. 6 can be arranged as like so, as a 1 foot by 6 foot arrangement, or it could be a 2 foot by 3 feet arrangement, but it cannot be arranged. The number 6, if you have 6 of these little square tiles, they can't be arranged into a square so that you have the same number on both sides of the square, at least not with whole numbers. So 9 is a square number. And doing the opposite of the square is called a square root. A number whose square is m is called the square root of m. It's written with this symbol here, square root of m. So for example, 3 is the square root of 9 because the square of 3 is 9. So these are opposites of each other, saying 3 squared equals 9 and saying 3 is the square root of 9. These tell us like the same relationship between 3 and 9. All right, so let me just draw you a picture. Saying 3 is the square root of 9, that's saying let's start with a square, which is 9 square feet in area. And what you're trying to do is find what the lengths of the sides would have to be. So because it's a square, they have to be the same. And in this case, it should be 3 feet by 3 feet. So if you want to keep that picture in your mind when calculating square roots, this really helps, I think. All right, let's do the following computations. Let's look at 0 squared. So remember, 0 squared means 0 times 0. 0 times anything is 0. So it's the number 0 in a box. So what's the square root of 0? Well, what number squared equals 0? I just found that 0 squared equals 0. So the square root of 0 has got to be 0. The number squared that equals 0. 0 is funny. All right, now let's find the square root of 25. What number squared gives us 25? So the answer is 5. 5 squared equals 25. So the square root of 25 is 5. Square root of 0 is 0. 0 squared is 0. All right, let's move to another one. What number squared gives us 121? So this one, some of us have memorized, but not all of us. So let me just think about what it might be, and I'll figure it out by trial and error. What number squared equals 121? Well, I know that 10 squared is 100, right? So it's got to be bigger than 10. So let's try 11 squared. 11 squared is 121. Since 11 squared is 121, 11 is the square root of 121. Now there is also a square root button on your calculator, but I do want us not to use that unless we're doing square roots of non-square numbers, because my hope is that you memorize all the perfect squares up to at least the square of 12. All right, now let's do negative square root of 144. So whatever that's going to be, the negative is outside of the square root. So really what I'm going to do is I'm going to think of what's the square root of 144 and then put the negative sign on the outside. So let's think, what number squared gives us 144? It's got to be bigger than 11. So we try 12. 12 squared is 144. So negative square root of 144 is negative 12. All right, so let's write out the perfect square numbers up to a certain amount. Of course, 0 is a perfect square number. And 0 is more like, instead of being a square, it's like a degenerate square. It's almost like just a point. It's 0 height, 0 length. So 0 is a perfect square number. 1 is a perfect square number because it could be thought of as 1 foot by 1 foot. Square root of 1 equals 1. Here, square root of 0 equals 0. Now, the next square number, think about 2 squared. This is the number 4. 4 is 2 by 2. Square root of 4 equals 2. The next square number, the next number that can be arranged into a square, would have 3 on one side, 3 on the other. And that's the number 9. So area 9 inside here has 3 on one side, 3 on the other. Square root of 9 is 3. Let's keep going, but then I can't really draw pictures anymore because they're getting too big. The next square number, the square of 4 is 16. So square root of 16 is 4. Square root of 25 is 5. The next square number is 36. Square root of 36 is 6. The next square number is 49. The square root of 49 is 7. The next square number is 64. Square root of 64 is 8. Square root of 81 is 9. And then, of course, we have the multiple digit ones. So the square root of 100, 100 is our next square number. Square root of 100 is 10. And then we just found that the square root of 121 is 11. And also the square root of 144 is 12. And we can keep going with this list, but these are the ones that it'd be nice if we could recognize when we see them. All right, go ahead and do all the problems on section 5.7 you are equipped for, and see you next week.